All right, I'm going to go live. All right.
Go.
Let's
okay.
Go live. Cool, and we are live. Welcome everyone to meetup number 60 of the Data on Kubernetes community. Very, very happy to be here. It's a meetup. It's actually really a laboratory. It's kind of in its own category. Nevertheless, we're very excited to be with a wonderful speaker who we've had multiple times. We're just talking about the amazing numbers, the amazing turnout that we get every time we do something with Alvaro. Alvaro is no stranger to our community. He was one of the first people that I met in the Data on Kubernetes community when I got started last year. We both live in the same country. We're both in Spain. Still need to meet each other in person. I need to get down to Madrid more often, but I'll definitely be doing so. Just a couple of things before we get started. This is a lab, all right? This is not a traditional meetup. So we want you to have your computers ready to go with your Kubernetes cluster ready to go. Alvaro will have more technical instructions on that. Alvaro's got some wonderful folks from his team at OnGres that will be here in the chat responding to questions. Alvaro will also be adding some links to the Stackdress Slack if you have more specific detailed questions that you want to ask there. Alvaro himself will be addressing more general questions. If you have them, I will be getting to them in the chat accordingly. Always remember that you can follow us and interact with Alvaro. Very easy to get in touch with. Twitter, LinkedIn, our BYOK Slack, Stackdress Slack. Wonderful person. Very, very good at answering questions. This is the third time that we're having Alvaro on. We still need to do a meetup in Espanol at some point. We can talk about that later. Anyway, that's pretty much all I had to say for today. Always excited to be here. Alvaro, how are you doing? How's everything in Madrid? You were somewhere else today and had to fly back. What's going on?
Yeah, I was in Barcelona at the Mobile World Congress, the YAMLs.
Oh, very good.
So yeah, I stayed for Monday, Tuesday, and Wednesday morning, and then flew in a couple of hours ago, just in time for the meetup.
Very good. How was the Mobile World Congress? Just out of curiosity, with different event structure and style and all that.
Let's say that I understand why they did it this year, but it's the first time I've been to the Mobile World Congress, but it was empty, and the big players were not present, and I understand all the reasons. Other than that, I enjoyed it. It was good. It was more focused on the Farrell conference within the MWC, which is 4 years from now, which is more focused on startups. So actually, that was even more on my areas of interest. So I enjoyed it. It was good.
That's good. Very, very good. And Alvaro, what are we going to be doing today? Somebody said something about Postgres on Kubernetes. What's that all about?
Postgres. Here I am, right?
Cheating.
Yeah, it's going to be all Postgres, all Kubernetes, and so Postgres on Kubernetes. It's everything we're going to be doing, as you put it very well. I hope you all brought your Kubernetes cluster with you. If not, I'm going to also go through the steps of getting up and running a Kubernetes cluster. The example I'm going to show you is with AWS. You can do it on any other environment, on GKE, whatever you feel comfortable. But I'm going to show an example of getting your cluster with Amazon on EKS, the managed Kubernetes service. So if you didn't bring your Kubernetes cluster today and you want to spin a new one, I'm going to do it in front of you. So you can also do it with me. Just open your Amazon account and have it ready for creating an Amazon cluster. Or otherwise run and do it in a different environment. But I want you all to get your hands dirty. I'm going to get mine, and I'll probably fail because it's a demo. It's going to be a long one. There's, 100 commands. Something will break at some point. I apologize already in advance for that. But I want you to get your hands dirty too, because if you do it well, at the end of the session, you're going to leave with a production quality ready Postgres cluster with tuned config, with high availability, with connection pooling, with monitoring, with backups, like everything you ever needed for running a production cluster Postgres, you're going to get it at the end of the session. So it's okay if you just want to sit on the couch and relax and enjoy the session, but I bet you're going to enjoy it more if you're going to get your keyboard, used to that this afternoon or morning, whatever.
Wherever you are in the world, yeah, we got folks from different countries. With that in mind too, it's kind of interesting. We have a technology like Kubernetes that's relatively new. No matter what companies are saying, if they're asking for someone with 10 years Kubernetes experience, probably gonna have trouble. But Postgres, on the other hand, you can ask for a lot more experience on that. How old is Postgres exactly?
Well, it's got a long history, right? It started first of all as a project called Postgres, which means post ingress. It was after ingress, and this was part of the research work at the University of Berkeley, California. And it started as such, if I recall correctly, around the year 1986. But that's honestly not the Postgres we know today. It was even written in Lisp, part of it, the first version, right? Then, so what we know as Postgres mostly started as Postgres 95. It was called Postgres 95, which was when it became kind of a community project, open source community project. And then in 1996, gathered the name PostgreSQL. So we can consider 1996 as the real start of the project. So we're talking quite a few years, definitely.
All right, good. So we do have that historical background. Getting some more folks joining in right now. And Mohammed has a question. He's asking, he's got an Oracle Kubernetes cluster. Is that okay?
Yeah, it should.
Should be. All right.
Yep.
Mohammed, if you have any issues, just put them here in the chat. Someone will help you out with it. Don't worry about it.
Yeah.
That being said, Alvaro, I don't want to take any more of your time. Like I said, we scheduled for folks that are just getting in now. We did schedule this for 2 hours. It might go a little bit fast. It might be a little bit quicker. It might take a little bit longer. Don't worry. It's definitely worth hanging around no matter how fast or long it takes. So without further ado, Alvaro, if you want to get started, start sharing your screen. I will stop sharing mine.
Thank you.
I will disappear into the darkness. All right, all yours.
Okay, excellent. All is okay with the screen?
Yep.
All right. So what we're gonna do, as I said before, first of all, we're gonna create a Kubernetes cluster. Just in case you wanna see how it is, you wanna do it in your own environment. As I said, I'm gonna do it with Amazon AKS. It's one of my favorite. It doesn't matter, you can do it anywhere. So I'm gonna do it. This operation is gonna take 17 minutes approximately. So I'm going to start right away because because this is going to be a blocker for anything that we're going to do later. So I'm just going to go directly and create the Kubernetes cluster on Amazon so that also you can see that I'm absolutely starting from scratch. There's nothing in the virtual world right now, nothing is physical anymore, that we're going to be using today, right? So again, both from the perspective that I want to do it from scratch so that you see there's nothing, absolutely nothing prepared, and consequently anything may break. But also for you to follow my steps. If you didn't bring a Kubernetes cluster and you want to do it with Amazon, then let's just go and do it. And then I will explain a few other things. First of all, what I'm going to be following is the instructions that I wrote here on a repo. So let me share this. I'm going to share this in the YouTube channel. So you have this information here. Also, I wanted to say that as Bart said, I'm going to be taking any questions you may ask. Bart, feel free to interrupt me anytime with questions. But I'm going to take mostly general questions, conceptual questions. If you have a particular problem, like saying, "Oh, I'm getting this error in my environment," I don't have the capability to address those questions during this session because there's 150 of you attending the session. So I don't have that many hands and eyes and ears. However, I asked part of my team to be alert. So share them on the chat. And also I'm going to share and invite you to join the specific Slack channel that we have for Stackdress. Stackdress is the software we're going to be using for this demo. So for your specific environment, I definitely recommend you to go into this Slack or Discord. I'll share the links for both. And so you can definitely go there and ask any particular questions about your environment. So those links I'm sharing here in the YouTube channel are, you also see the screen, Slack, Stackdress.io, and same with Discord. Stackdress.io. So I really encourage you to go now there while we start preparing and you have the environment ready to ask any questions about your particular environment. All right, so what I'm going to do is go to the first URL that I shared, which is this hands-on lab, and let's create a Kubernetes cluster. I'm going to create this Kubernetes cluster right now without further ado because it takes just 17 minutes. Then I'm going to explain what we're going to be doing in detail. If you want the precise instructions, here we have them. So first of all, prerequisites, kubectl, Helm version 3, and Git. Probably you all have them already, right? Shouldn't be a problem as of now. So let's set up this cluster. As I said, I'm going to be using an Amazon EKS cluster. So we also need extra tool called EKSCTL, as well as the Amazon command line interface. You can also do from the web console if you prefer, but I'm a CLI guy, so I'm going to do it from command line. It's also easier to automate. So let's just go and create this cluster. I'm going to set some variables here. You should be able to see well the command line. So I'm going to create this because I'm in Europe. Let's create it closer to me. But you can obviously choose the region that you want. Then I'm going to set up a cluster name I'm going to be using here. I'm going to call this Stackdress because that's the software we're going to be using, but you can pick obviously the name that you want. And because I typically manage several Amazon accounts, I'm going to select a profile. If you don't know what is this, you don't need to set this variable. If you work with several profiles, you already know about this, right? So anyway, you can have different profiles with different accounts. I'm just choosing this one. And so to create a cluster shouldn't be more difficult than this. Just run this command. And this is the command that will start creating the Amazon cluster and will take, as I said, approximately 17 minutes to run. At the end of this command, we'll have an empty Kubernetes cluster, which is exactly what we want for proceeding here. So here you have the screen, you have the command, I shared the link, I think we should be ready to go. And if you brought your own Kubernetes cluster, you just need to watch the screen. If you didn't, and you want to create in Amazon, just follow the steps. And in around 17 minutes, you should be able to have your own cluster ready. As a reminder, this may incur in some cost, whatever you're using it. So just remember to tear everything down after the session if you want to.
Alvaro,
otherwise,
sorry,
don't
Alvaro,
blame
quick
Yep.
question. Can you put the repo link again in the YouTube chat?
Oh, yes, absolutely.
Yep.
This one.
Or maybe can you also just share it with me on Zoom so I can paste that as well?
Isn't it pasting it correctly?
I don't, at least on mine, it's not coming up. So just in case.
Okay.
Yeah.
All right. So I'll also share the links.
Perfect.
Just in case for the Slack and Discord communities, so that anybody can go there and ask questions about your particular environments that the team will be happy to share with you, right?
Yeah. Good.
Okay. So everything is on. Bart, you believe we're ready to go with this? Any further question? Anyone stuck? Please, if you get stuck, something, just let us know, because we're going to do a lot of things with this. I don't want you to get disconnected. All right, I'll take that as a yes. So now that we're creating this Kubernetes cluster, let me explain what we're going to do here. Actually, because it's a pure hands-on lab session, I decided explicitly not even to create slides. So what we're going to do is talking about building Postgres on Kubernetes. There are several ways to build Postgres on Kubernetes, from running the Postgres container. There's an official. Official means that, you know, from the same team that actually creates Postgres, that is on Docker Hub. And you can just your kubectl run and get a Postgres container running, Postgres pod, of course, in Kubernetes running. But that's not going to take you very far. That's not going to be production quality. There's also several Helm charts around that will allow you to deploy Postgres pod or several with even with some high availability, but they're also a little bit limited in terms of what you really need around Postgres to run in production. And last but not least, there are several operators. The operators for Postgres are essentially the software, well, you know what operators are, right? That control the whole life cycle of a cluster, in this case, Postgres cluster. For this particular case, we're going to be using a software called Stackdress. If you don't know about it, you can go to the website. It's called stackdress.io. Let me just share the link also here. And sorry. And so is this software. Stackdress is an open source software for running Postgres on Kubernetes. And the reason why I want to be using it, well, disclaimer, because I designed this product and I work for this software. But the real reason why I wanted to show it is because it is designed with two main principles in mind. The first one is to be easy to use. And this sounds a bit awkward because databases, doesn't matter whether they're easy or hard, right? They're core components of every data infrastructure. But the reality is that this is quite important. Postgres is very easy to install on your laptop. Probably apt-get install Postgres will get you up and running. But setting up a Postgres in production is a whole lot more complicated. You really need to bring a lot of components that go around Postgres for building this production quality workload. You need high availability with automatic failover. You need monitoring. You need connection pooling. You really need connection pooling in Postgres. You need backups. You need processing the logs, and you need tune configurations and a lot of components around this. And there's so many tools in the Postgres ecosystem, each one with its own different configuration, that actually, even for an expert to create some software to automate deployment of Postgres, let's say you want something like a database as a service, like RDS, but on your own Kubernetes environment. This is a work of weeks for a Postgres expert to do it production quality, do it well, and to do it automated. So one of our goals with Stackdress is to make Postgres easy, to hide all this complexity behind very simple, very high-level interfaces, which, as we will see today, are either command line or via the web console, click and just click with the mouse. But they're here hiding all this complexity that Postgres requires to operate in production. But the second reason why I also wanted to bring the software today is because not only we're automating the deployment part, but we're also helping you automate the operational part. What is so-called now day two operations. And Stackdress has made a significant bet. We're still at the beginning, but a significant bet into automating this day two operations. As a Postgres DBA, I can tell you, probably you know, that there's a lot of things that you need to do besides what even managed services provide. For example, managed services will not repack your database to get rid of the bloat, will not vacuum your database with manual vacuums, will not help you run a benchmark, and many other operations that are required for keeping your database healthy. Obviously, they're not going to tune your database for you. So there's many operations that in Stackdress we have already automated and hidden behind very high level, very simple interfaces to use. So this is what I'm going to be showing to you today. As we already said many times, I hope you have your Kubernetes cluster ready. Just get out of your comfort chair, stand up, and let's get it started, right? So just before starting, because I'm sure this hasn't finished yet, let me quickly go over the main features of the software that we're going to be using, so you get a glimpse of what we're going to be using. Very quickly, first of all, first characteristic is that this is Postgres in your environment, so you own it. In a managed service, you don't even have access to the super user in Postgres. Here, you'll have access to the super user. Environment is yours, you can do whatever you want with it. It comes included with automatic failover and high availability. This is thanks to a component called Patroni, very well known in the Postgres community, which handles this. And it's totally integrated. There's nothing you need to do to install it or configure it. It's always configured, always exists by default. There's even no way to remove it. You always have high availability. Even if you have one node, you can add later a second and it will start replicating and it will promote either if one fails. So it's completely built in. It manages Postgres backups. By Postgres backups, we mean what is called continuous archiving, which is basically a base backup or a snapshot plus the differentials in Postgres called wall files through a mechanism called wall archiving. Again, this might be complex, but it's automatically handled for you. You just need to provide a configuration. We'll show how to do this because we're going to create this. We'll provide this configuration. We'll set up an object storage like an S3 bucket, and backups will go there. And they're completely managed. Even the rotation of backups, when to keep a sliding window, it's all controlled, all automatically done for you. Even though we're not going to be using it today a lot, it comes with a fully featured web console. It's pretty nice, supports light and dark mode, which is pretty important, and allows you to do everything that you can do from the command line, and everything you can do from the command line will also be reflected on the web console. So they're interchangeable. We'll show a few bits of it, but for today, we're going to be focusing more on the command line. It comes with integrated monitoring. So if you have installed Prometheus, Grafana, Alert Manager, all their components, they're stacked into your Kubernetes cluster, and you provide some configuration flags that also we're going to see, you'll be able to fully integrate Stackdress with this stack, which means A, you'll get metrics pushed to Prometheus. B, you will have a specific Stackdress created dashboard for Postgres, which comes with very advanced DBA, Postgres DBA metrics that you want to see. And also, it will be integrated, if you wish, into your web console. So you can go to Grafana directly, but you can also just stay in the web console and see all the metrics, as you can see in this screenshot. One very interesting characteristic is that it supports distributed logs. And I'll explain a bit later when we get there exactly what it is and how interesting this may be. And one of the things we're going to be demonstrating today significantly is that this interface is the CRD. We're leveraging the Kubernetes CRDs to the extreme. Just to recap, a CRD is a custom resource definition. It's basically, if you think of Kubernetes as an object server, which is the way I like to look at it, it is an HTTP server with an API that serves objects. What are those objects? Doesn't really matter. They are what they're defined in Kubernetes. And once you create or update or delete these objects, they may trigger some actions. Those actions are triggered by the controllers that may, for example, create resources. But these are just objects. And Kubernetes comes with some of them, like a job or a pod or a service. But there's also the possibility to create your own objects. And those are called CRDs, custom resource definition. And when you create them, they're called CRs, custom resources, that you create stemming from this CRD definition. And the way we have designed Stackdress is by leveraging them significantly. So we have 6 or 7 CRDs. We're going to see all of them, I think, today. And these CRDs are designed, as I mentioned before, to be easy, and easy from the perspective of not requiring you to be a Postgres expert to operate this, and be very high levels. They're hiding all these details. And because they're YAML files and everything can be managed from YAML files, you don't need to install any plugin for kubectl, any other separate tool, even though you can do that too because we expose the REST API. But for the most part, you can manage everything with kubectl, which means that essentially it's 100% GitOps ready. You can just do commits on a Git repository and deploy Stackdress clusters, modify Stackdress clusters, and do whatever you want. Also, it integrates connection pooling. As I said before, this is very important in Postgres, and there's a lot of discussion about this topic. I have talks just on this, so just bear with me. And one very cool thing is that we have also integrated into Stackdress the Envoy proxy. Envoy proxy, we helped develop with help with the Envoy community, we developed a Postgres filter for Envoy, which basically intercepts the Postgres wire protocol and is able to expose metrics from this wire protocol to Prometheus, and also is able to terminate SSL. So you can have encrypted connection to the Envoy proxy, which runs a sidecar, and from there, an encrypted connection to Postgres. And comes with an expertly tuned config, or at least humbly, we should say just a tuned config. And many parameters are tuned for you, and I'll show you later how you can check this. So Postgres configuration by default is quite conservative. So this is less conservative, it's more production ready. And the container images that are used are based on Red Hat UVA. So any question about this, about the environment, about the software itself, or about this feature set that I just mentioned right now? Because I guess the cluster is going to be almost ready. Doesn't matter because it's 2-3 minutes more, but I'll start explaining already what we're going to do today and the first steps. So, as I said, any question before we get started? Okay, I see some comments on YouTube about stack ready. Interesting. All right, so Go to this Git repo here with the hands-on lab. Just one last time, I'm gonna share the link here, and we're gonna get pretty much started. So go to the README. We have the prerequisites supposedly, and we are creating a Kubernetes cluster, so we should be ready soon. What we're gonna do first? So the first thing we're gonna do is install some dependencies. This is optional from the perspective that Stackdress do not require to have these dependencies installed. But this dependency is Prometheus and Grafana. We want to see monitoring, we want to see graphs, right? So let's install this. You can do without doing this, and you can obviously do with your own Prometheus or Prometheus compatible software, Thanos. It will all work well. But if you deviate from what we're going to see here, you probably need to make some adjustments. But for the most part, it is quite simple. So basically, what we're going to do is create a specific namespace called monitoring. You can name it the way you want, obviously, for installing here Prometheus. Then we will create a separate namespace for Stackdress itself, for the Stackdress controller and the REST API. And finally, we'll create a third namespace, which is what we call demo, where we're going to create the Stackdress clusters. So, okay, we still need to wait a bit more. Should be there, almost ready. We'll create this namespace, and then we're just going to install the Prometheus stack, this kube Prometheus stack from the official Prometheus repositories. This, you may need to add this. I will not need this because I already did this. And we're installing here with Grafana. So again, you can install in a different way. If you install in a different way, if you have it already installed, what you may need to adjust in the next step, which we'll just see here, is some parameters regarding the host or the namespace or the username or password of mostly of Grafana. Because basically what Stackdress is going to do is, on one side, Stackdress will deploy a sidecar with Prometheus exporter, which is the Postgres, one of the Postgres exporters available for Prometheus, and we'll send the data to Prometheus. For this, it also uses service monitors, which is a way for discovering endpoints, and it makes it very easy. But to integrate with Grafana, we do a couple of things. First of all, we create that specific Stackdress-specific dashboards into Grafana, and for this, we need to access the API, for which we need to access the username, password, and host. So we're going to need to take notes of these parameters. And yeah, and then we embed the web console. So for this, we need to log into Grafana. So that's why when we do this, this uses a default service where Grafana is accessible, as well as default username and password. If you are doing a different installation, you will need to change these parameters later on. So come on, as usually in the demo, it's taking a bit longer than expected, but should be ready very soon. Any question at this point? Or I'll drink some tea.
Conversations going in the chat, but yeah, interaction between old friends and people mentioning Stack Redis. We got a lot of different comments.
Okay. Well, yeah, this is progressing, but it looks like it's going to take just a little bit more. All right, so let me explain what's going to be next, and then we'll just backtrack a little bit to make sure everything is well understood. So first of all, as I said, we'll install Prometheus with its dependencies. With a stack, nothing really special here. Then we're going to install Stackdress. Stackdress is also available as a Helm chart. So first, as I mentioned before, we'll create the namespace, and then we'll do a Helm install Stackdress. For this, we're going to be using, first of all, we're going to be using version beta 1 that was released yesterday. So yay, freshly baked for you. And then we may want to pass some parameters. These parameters are what I was explaining to you before. First of all, do we want to support this auto embedding of the Grafana? Probably yes. So then it's not the default, just in case you don't want to do this. So set this variable also. And then we need to pass the Grafana host username and password. The host is going to be, if you install it from this default stack, it's going to be called Prometheus-Grafana, and it's going to be sitting on the namespace where you installed this. So if you change the namespace, for example, in the step before, also remember to change it here, otherwise it will not work. So this is actually the name of the service, where you can also check the name of the service once this is published and adjusted. So this is the host. And about the username and password, by default, the username is admin, unless you decided to change it. And the password is called prom-operator if you install from this stack. If you install in a different way, might be different. If you change it, just set up the password that you may want here. And then we have this parameter. This parameter is also important to understand. As I mentioned before, Stackdress comes with a web console. And this web console, how do you access this web console? There is mainly two options. One option is to use a load balancer, and then the service will be published with a public IP, public DNS via the provider where you're running this. And so far, so good. Quite easy to set up. This is the method I'm going to be following today. Now, if you're running on an environment where you cannot create a load balancer type of service, or where you are running on Kind or Minikube, and just doesn't have this capability, you can also set this to cluster IP. In this case, it will be exposed only within the cluster, but then you can trivially use port forward to get access to the web console. So both methods will work. Just select the one that you want to have here. Just bear in mind that if you use a load balancer, it may incur some extra costs, but it's easier. So, and then the version. That should be it. And the cluster is ready, so I think we can get started. Let's just make sure that we have access to the cluster. The previous command injects valid.config configuration. So yes, it works. And if I recall correctly, we selected 3 nodes, which we'll be using for the demo. Good, we're all good to go. So let's get started. Let's install Prometheus first. So we create the namespace monitoring. I'm going to be just copying and pasting. So you see that there's no trick. I want to be doing the same steps that should be doing. If I just go too fast at some point, let me know. I'll try.
Yeah, and one thing, Alvaro, if you can you make the font a little bit bigger?
Oh, yes.
Yeah, because I see it great here on Zoom, but sometimes when these things go to YouTube, it gets a little bit blurrier. So if you can just make it a little bit
okay. Yeah, actually, this I should make it a bit bigger too. And this one also.
Yeah, that's good. And then where you're putting the commands in, if we can zoom in a little bit there as well. Yeah.
I think this is. That's allow me to zoom more.
No, I can see it. I can see it fine. All right. So yeah, should be good.
Okay. All right. So I created this namespace. Sorry, that will not work. That should work. Yep. See, here we have monitoring, and let's install Prometheus. First of all, I will add the repo. If you don't have it, I have it. So it should be node op. Yep. And now let's install Prometheus. I'm testing here with a version 13.4, which is a version that is known to work. Probably others will also work. Risk is on you. And I'm setting the flag Grafana enabled to true because I want Grafana. So this will install, and we will check right now. It will install Prometheus, Grafana, Alert Manager, plus the components that they require to operate. It is also possible to leverage Alert Manager with Stackdress. Stackdress supports specific alerts being specific of Postgres events. So if you then go and configure Alert Manager to send you alerts to your PagerDuty or Opsgenie or whatever you use, then you should start receiving, when events happen, alerts that are specific for Postgres. So they are pre-configured for you. We're not going to see this on the demo today, but you should be able to do this on your own. It's documented, and you can define your own metrics too. So this process should not be very long. It should take up to maybe 1 minute at most, and we'll be able to have Prometheus with all the stack installed. As I said before, this is a prerequisite. This is a dependency that is optional. If you don't want any kind of monitoring, you can skip all this. But probably you want to see beautiful graphs, as I do. So bear with me and install also Prometheus. It's the same free. Everything is open source here. All right. While this works, I'll just, for your information, check that it's installing stuff. Not yet. Okay. We'll need to wait a bit more. All right. Once this is going to be installed, then we're going to install Stackdress. So we'll create the namespace. We can start doing this in parallel. And then we will install Stackdress. Given that here, I'm just going to be using, I don't need to make any changes to the parameters because installing from the default stack, the service is going to be called exactly like this with this username, this password. I want to create a load balancer. I'm on EKS, so on Amazon. And so a load balancer is going to be very convenient for me. And I want to auto embed Grafana. There's nothing else that I need to change here. So I didn't hit enter. So this command is not running yet. I'm just going to wait until the previous one finishes. Oh, interesting. That's why it failed. It's interesting because this version should work. Okay, let's try again. Let's open a new shell and see what it's doing. Still nothing. So I hope the repository, this version is ready. Let me just double check the command here. We also have on the website the Stackdress.io, the tutorial, the documentation, and within documentation is the tutorial. Let me just make sure that that command is correct and I didn't mess it up. Q Prometheus stack. Yes. From Prometheus community home charts, right? So, okay, yep, it worked this time. Sorry about that. So for some reason, the repo is not updated. Okay, so it is deployed. The monitoring stack is deployed. And if I go here, I should see pods for, yeah, okay, this looks better. Cool. So we have Prometheus, we have Grafana, and so forth. This is all that in the node exporters. We have 3 because we have 3 nodes. Makes sense. So yeah, and sorry, Prometheus was not this one. It's this one, but we have alert manager. Ready. So we're good to go. Let's go to the other shell. This one we can close for now. And here, let's start running this command. So if all goes well, and this will take slightly more, 1 minute, around 2 minutes, we will have Stackdress Beta 1 version installed. To check that this is going to be installed correctly, apart from the message that we will see in the screen that comes from Helm, we will be able to see on the Stackdress namespace the following, among others. 2 pods, one which is a Stackdress operator, the controller, we want to be more precise, and the REST API, which includes both a REST API and the web console. And it will also create a service to expose this web console, which is going to be of type load balancer in this case. Cool. Again, also, if you need some information, you can always go to the documentation on the website and check there. As a reminder, if you face any difficulty in your own environment, please go to our team in the Stackdress community Slack or Discord, and you'll get probably some help there. So once this is ready, what we're going to do next? Well, if everything goes well, we shall see a message like this, Stackdress operator, version that is installed. And here it gives us a few information. We're not going to worry about this for now because we're going to use most of this information very soon, but you can read this calmly later on. And this is the pods that I shall see once this is going to be installed. I hope you're also following the same steps. And in a few seconds or minutes, you're also going to get the operator, controller, and the REST API running. Once this is done, we will call it Stackdress install. As you see, it's just one command. And then we'll start creating clusters, which is obviously what we wanted to do here. Cool. Looks like of course, it's because of the font size, we cannot see very well. We can scroll up. Yep, there we go. And so if we just query on the Stackdress namespace, for example, for the pods, we will see that we have the operator and the REST API. Everything is running. We're absolutely ready to go. Any question before we start creating clusters? Just to recap, we have created a Kubernetes cluster from scratch. Then we have created several namespaces. We have installed Prometheus and Grafana as stack. And we have installed Stackdress with a single command, passing some variables to basically allow embedding Prometheus and Grafana. So we'll have monitoring. And we have already Stackdress 1.0 beta 1 installed. Good to go? I'll take it as a yes. So let's go. Let's create a simple Stackdress cluster. Simple does not mean anything bad. Doesn't mean that this is not powerful enough. It's just I want to show you the bare bones, the minimal unit that you need to create, and then we will make it more complete. So let's go and create a YAML file with this content. It'll be pretty straightforward. I'm just gonna actually let me use this as the shell, and let's call this simple, for example. So what this YAML file contains here is, first of all, we see that we're going to create an object of type SG cluster. SG is a Stackdress. Everything's going to be SG something. And as I mentioned before, we're going to be using several CRDs, these custom objects that Stackdress provides for you. And they're meant to be designed high level. We're trying to hide all the Postgres expert details from you so that you don't need to worry about them, unless you want to. And if you want to, you can dig very deep. We'll show you later. But if you don't want to, you should be able to create clusters with basically no Postgres expertise. As long as you understand Kubernetes, and I guess everybody here does, as long as you have basic Kubernetes administration skills, now you're going to become a Postgres DBA too. And if you believe any of the parameters I'm going to be showing today are exposing some Postgres internals, if you believe they're not high level enough, please open an issue. Actually, I'll explain you how to open an issue also. All Stackdress is in GitLab. So if you go to this URL that I'm going to copy on the chat window also, you can see all the issues there. They're public. And you can go here to the issues. And you can open a new issue for anything, right? Especially if you consider that some of these interfaces are not high level enough. So first of all, well, AP version, Stackdress.io v1, kind SG cluster. This is the name of the CRD. This CRD, you'll see that can become quite advanced. There's a lot of things you can customize in a Postgres cluster as created by Stackdress. Obviously, if you want documentation about it, just go to the documentation. And there is an area here, which is the CRD reference. And under the CRD reference, let me make this font a bit bigger, you can see all the information about all the CRDs. Let me also copy this for your reference. Okay, so we create an SG cluster, which represents an Stackdress cluster. We're going to give it a name, simple in this case, and here are the minimum amount of information you need to provide about your cluster. How many instances do you want? It's going to create, in this case, 2 clusters of Postgres. Sorry, 1 cluster with 2 instances, 2 nodes, 2 pods. It's going to use the latest version available. This latest is going to be transformed by the mutating webhook into the latest available numeric version that Postgres has. But you can use latest if you want, or you can say 12.4. And also for the pods, you need to specify for the persistent volume the size that you want. So by default, Stackdress is going to be uses Stackdress uses stateful sets, which use persistent volumes, and here you just specify the size. This is the simplest use case. should be, as I said, high level and simple to understand, simple to use. If I then go and apply this file, it should create this cluster. I'm using default namespace, so if I just watch on what's being created, I should see indeed that the cluster is being created right now. Each pod here has 6 containers. We're using several sidecars for different capabilities of the system. And if it all goes well, in a few seconds, we will have our Postgres cluster. And this is all that in reality is needed to get a Postgres cluster. This Postgres cluster has the following features. It has Patroni with integrated failover and high availability. It provides replication, so one pod is going to be replicating to the other. It provides connection pooling that is running by default. You can remove it if you don't want it, but we encourage you to use connection pooling because in Postgres it's quite important. It comes with a tuned config and Envoy proxy and a few others. So it's quite packed, the amount of services and capabilities that are being deployed just with this 11 lines of YAML, out of which only the spec part is relevant. So this is 5 or 6 lines of YAML. So this is all that we had to do to create this cluster. And in a few seconds, beginning obviously takes a little bit more because it's downloading containers. Now the process should run faster. So we have already simple 0, which is the first pod that was created, and simple 1 will finish soon. So once we have this, what can we do? Well, obviously, what we're going to do is check. Here's this checks, the same I was doing, to see that there is a Postgres cluster there, right? That there is Postgres. So far, you just need to believe it. The other thing we can also do is describe this CRD to see what aspect that it has, and for example, what real version is behind the scenes, because I just said latest. So let's actually do this. This is a command. I'm going to type this, describe this CRD. And here I can see that it's created by this operator version. It's important for internally for upgrades. Some configs here. I'll explain later what they mean. And here I see, for example, that it was resolved to this Postgres version. Okay, so far so good. 12.6, and that's all what I want to show for now. The cluster is created. So hopefully they are both ready already, and we have our Postgres cluster. Now let's demonstrate that there's indeed here a Postgres cluster, that I'm not lying. So how do we access Postgres? In Stackdress, we're going to access right now in a way that should be used normally only for DBA tasks, not from applications, right? The Stackdress pods contain several containers. One of them is called Postgres util, and Postgres util contains tools for administration, tools for Postgres administration. And this container runs as a sidecar. So it's going to be on the same process space, on the same file system as the main Postgres container, which is called Patroni, because it also contains Patroni. And so it's very good for administration because it shares the same space, and you can really administer Postgres from a low level. So how to connect? Well, this Postgres util container contains a tool called psql, which is the usual command line interface for accessing Postgres. So it's just very simple. I just need to run this command. So I'm just going to do a kubectl exec in the terminal on cluster simple on the container Postgres util. I'm going to run the command psql. And psql is, you select an appropriate pod. So this would be the correct command. So on pod simple -0 container Postgres util run command psql. And connects to Postgres. So first of all, yay, we have a Postgres here running, right? I was not lying to you. There is a Postgres here, and yes, you see it's version 12.6. So yeah, I can connect to Postgres. That's good. Now, why didn't I ask for a username or a password? It didn't because by default, pSQL with no further arguments tries to connect as the Postgres user to a Postgres database, which always exists. And it doesn't ask for a password because by default, this is running in the same space as I mentioned before, and it's connecting via Unix domain sockets. And Postgres can be configured, and Stackdress configures Postgres in this way that if you're connecting via Unix domain sockets, Postgres can authenticate the user by asking the operating system, if you are the user who you are telling you are. In this case, we are saying, hey, we're Postgres user. And because this is running up as also the Postgres user, the OS says, yes, okay, you are. Then Postgres authenticates without a password. This is pretty convenient. And here I can do anything, right? So actually here I'm proposing some commands. Yeah, so let's, for example, create a database. I'm going to call this database hands-on lab. I'm going to connect to this database, and I'm going to create here a table. We're going to call it one. And we're going to insert some data here. I'm going to use for this a function called generate series, which just generates numbers. And I'm going to say insert 1 million records, for example. So why I'm doing this, well, first of all, to demonstrate that there's a Postgres here. I should actually count this. Just to demonstrate that the table exists and show how it looks like, just numbers. Now, this is interesting because I'm just demonstrating that there is a Postgres instance here. But probably I also want to show that there is replication. That's the very first thing we want on a Postgres cluster, that there is replication. I'm guessing this is the next step. It is, okay, so I'm not lying. And otherwise I would have done it anyway. So let me now connect to simple one, which I'm believing is the replica. And well, I know it's a replica because simple zero I could write to it, right? So it's obviously a primary node. So now let me connect the same command, except I'm going to do simple one. So this will connect to the replica. And if replication is going, I should see this database called whole. And yes, there is. Guys, 42 megabytes. And I should be able to connect here. And I should be able to do table. And I should see some data. Yeah. So that's good. I should also be able to select same count. Excellent. So replication is working. That's great. How are you doing over there? All is good? Are you getting your monitoring Stackdress installed and first cluster deployed? And are you able to connect to it? I really, really hope so. Obviously, otherwise there's the guide there, and you can follow it. But let our team know in Slack, in the YouTube channel comments, and we'll try to help. So this is good. Now, how did I know that simple zero was the primary? Well, happens that typically the first node is initialized as a primary, as a read-write node, and then others become replicas. But it could have happened. Any event that disrupted the network and a failover may have happened behind the scenes without me noticing. And as I said, Stackdress will handle this completely automatically for you. So there's nothing you need to do. But that didn't happen. Now, how can I check this for sure? Well, right now I'm running this command pSQL on the Postgres util container. But if I go to the Patroni container, it contains Patroni, which is a software for Postgres replication, for high availability, configures replications built into Postgres. And it has a command line tool, also has an API, and has a command line tool called patronictl, which supports some commands. One of them is list. So if I run this command, this is going to run this patronictl command on the Patroni container, and it's going to show me the state of the cluster. Here I can see that indeed simple zero is the leader in Patroni terminology. This is the primary, and Postgres running on timeline 1. So good. Now I know that indeed simple zero is the leader. I could have also called this function from Postgres, which is called pg is in recovery. That pg is in recovery. That if it says true, it means that node is read only. If it says false, is read write. And indeed, if I do this on 0, it will tell me that is false. So that's why I see that this node is read write. Excellent. So now I have already demonstrated. Remember, we just used the 11 lines YAML file, this 11 lines YAML file to create a Postgres cluster. And we have already demonstrated that there is indeed a Postgres behind the scenes that we can create databases and write data to it. We've also demonstrated that it's replicating. Now let's demonstrate that there's high availability here and automatic failover. So we have these pods, right? Let's kill one. By the way, I'm just running this by heart. Should get back to the script to make sure I'm not messing with you, but probably it looks like something similar. Okay, yes, we're going here, PD's in recovery. We have this database. Oh, yeah, we ran this command from Petroni. Yeah, we're gonna get to the same point. So the memory is normally terrible. Today it looks like it's working well. I'm surprised. So let's kill a pod, because why not? Delete pod simple 0. Let's delete the master. So when we're running this, the following is going to happen. First of all, Kubernetes is going to realize that simple 0 is dead. Then I'm just going to set a watch here to also watch to see the movie, and it will inform Stackdress. Stackdress is going to run the reconciliation cycle. It's going to say, hey, one of our nodes vanished. So let's create another one. Well, actually, to be honest, this happens because there's also a stateful set behind the scenes. And so Stackdress will start recreating the nodes. And you see the simple 0 is being created again. This is good news. Let's actually check Petroni's state. I'm connecting to simple 1. The simple 1 is still there. And we see that, oh, wow, this was fast. This may happen. That simple 0 is already the leader. But interesting, you can see that there's a swap in the timeline. So let me explain all this. First of all, a new node is created. But this container now starts quite fast. The disk is already there, so just the process, the container starts, and the new disk is attached. This process may be so fast that the number 1, the simple 1, which was the previous replica, is not able. Petroni works by holding a leader lock, and this leader lock expires after so many seconds. The default is 10 seconds. And this creation process may happen fast enough that this lock doesn't expire. And by the time simple 0 is back up, it can catches this lock. However, Postgres keeps a timeline. Timelines are like an epoch and like a term list. And because this node has been promoted right now from a state, was recovered, it increased the timeline. Now, all the nodes in a cluster need to be on the same timeline. So probably by now, Petroni should have fixed this, and both nodes should be right now on timeline 2, which means that both nodes are replicating correctly again. So this is quite interesting because we can see here that the cluster completely healed automatically. There's no action that we had to take, and we see that it was recovered from a state where we deleted one pod. And we can also delete the same with a simple 1, and the effect will be pretty similar, except that in this case, the timeline will not change. So we have demonstrated the replication, we have demonstrated high availability. I could also demonstrate that there's a connection pooler running here, but let's move on because we have a lot more stuff to see. Any questions? No. Okay, let's see the web console. I'm gonna stay most of the time command line, but honestly, we have Stackdress comes with a beautiful web console, and more importantly, it supports dark mode. So yeah, let's show it. This web console is exposed as a service. So let's create a service. This service is present on the Stackdress namespace. So let's list the services that are available here. And it's this one called the REST API. Because I use the load balancer, it created a load balancer, and this is the address of the load balancer. So I'm just gonna copy it and open. And important, use HTTPS : blah, 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 behind as a prefix for this, right? Because this REST API is just a self-signed certificate that is created dynamically during the installation of the REST API. You get this warning, but okay, blah, 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 advanced, yes, accept the risk, and continue. If you don't like this, no problem. You have several options. A, use cluster IP and then do a port forward, but this is obviously only for development purposes. Option B, supply your own certificates. You can do this on the installation as a Helm parameters. And option C, you can also opt for exposing this via HTTP only and not HTTPS, and then set up an ingress for your Kubernetes cluster. And this is probably the better way to do this, especially if you have other endpoints exposed, and then set up your own certificates as part of the ingress. So, but for now, it's good what we're doing. The username, by default, you've got admin, and the password. The password is randomly generated. So let's capture it. We can capture this one by basically getting this secret. So the password is recorded on a secret. And what I'm going to do here is, sorry, I'm going to paste this. And in order to hide it, I'm just going to copy it. But basically, this command will retrieve the secret of the REST API, which will get you the password that we're using here to access the web console. And if I go to the web console, yes, paste this, should work. Good. So we can see the web console. And here indeed, we see that there's a cluster simple with 2 instances, so forth. Let me go to dark mode. Yes. And here I can click here and I can see some basic information about the cluster, the load average, the CPU's memory is using, the number of containers, the state, primary replica. All here I know. I don't need to call Patroni. It's done for me, and a few other parameters, configuration, which configuration I used, services that it exposed. We'll talk about this a bit later. Backups monitoring are not configured right now, but we'll see later. So excellent. We can connect to the web console here, and we can operate from here. We could also create a cluster from here. I can just click here a plus and create the cluster. But I'm not gonna do it. I'm just gonna go command line today. So let me cancel here. Yeah, we can access the web console. Next step done. Let's go back to our. Let's move the step a little bit, and let's keep going. So another interesting fact that we can do here is that, as I told you before, one of our goals is to make this very, very high level. And so if we go back to the original simple YAML that we have here, here we say instances 2. How difficult would it be to scale up this cluster, for example? What would happen if I could set a 3 here? Well, it will do what you expect it to do. Kubernetes will detect that there is a change being applied here, will inform Stackdress, and Stackdress will get everything configured so that a 3rd node is spun up. And here we see that this 3rd node is being created. And actually, if we go back to the web console, we should also see here already, you see simple 2 pending state and is being created. And obviously, it will join the cluster as a replica and start replicating. So this is, as I said, one of our goals, to make this simple enough that operations that may be quite complex in other environments, like add a new replica, and especially if you want all scripted out, are simple as, in this case, editing one number. Cool. Let's wait until this cluster is spun up just to demonstrate that it works. And then we're going to just delete this cluster and create a more pro cluster. Well, I'm going to delete it. You don't need to delete it, but one of the also in Stackdress, we also want to embed some good principles, good practices. And one of them is do not run more than 1 Stackdress pod per node. Why is that? Because you typically don't do this in production. And so we enforce this with anti-pod affinity rules. If you want to avoid this, you can add to the YAML files 2 lines that will basically allow you to run as many Stackdress pods per node. But we didn't do this. We can do this as part of this. But so far, I'm just going to delete this to leave room to other Stackdress clusters. Again, if you want to do this, you can just go to the CRD reference on Stackdress cluster, and it's called non-production options. And here is, if you see the, oh, sorry, there's a small rendering problem here, but you set this disable cluster pod anti-affinity rule, and you'll get it done. So that's all it takes, right? It's pretty straightforward. Excellent. So cool. The node seems to be running. And if I, for example, call patronicetl list, I should see the third node. Excellent. We got the third node. It's a replica, timeline 2, no lag. Obviously, it has no traffic. That was easy. So let's delete this. How do I delete this? For example, it's very easy because I can delete all the resources associated with this cluster with just delete SE cluster simple, and I'm done. In a few seconds, this will be deleted. If I watch on the pods, I'll see that they are being terminated. All right, good. Let's move on. Let's create what I call a fully featured cluster. Any questions? That means everything is going well. All right.
In the chat. So, yep, good to go.
Awesome. Thank you very much.
Yep.
All right. So, yep. Well, if there's anything, let me know. Okay, so let's create a more advanced cluster. First of all, let's start to do things properly. So let's create a namespace, and we'll do everything on a namespace called demo. It's simple. And now we're going to start, before creating the cluster, we're going to create some configurations. As I said before, we're trying to enforce, guide you. It's not compulsory, but we're trying to enforce best practices because this software comes from the experience of Postgres DBAs. And they, myself included, have told us, self included, what do we really expect when a software fully automates Postgres deployment and management of clusters, and how to run them in production. And one of those problems that we have seen as a company, we have Postgres customers with hundreds of Postgres nodes. And for example, one of the problems that we have seen is that on some occasions, their sizes are absolutely heterogeneous. And that is a mess to manage, especially because Postgres configurations tend to have parameters or values of parameters that are related to the size of memory or CPUs, a lot of them actually. So if you don't standardize on sizes, you'll end with chaos, because then you have hundreds of different sizes of Postgres clusters with consequently hundreds of different configurations. That is very hard to manage. So one of the things we want to encourage in Stackdress is to bin or classify your instances in types, or we call it, as many others call, t-shirt sizes. So, just create your t-shirt sizes, call them extra small, medium, large, XXS, whatever you want, or use Amazon terminology and call M5 medium. It is up to you, but create some and standardize on those. You can create as many as you want, but this helps you standardize. Even more interesting in Stackdress and Kubernetes, because this is going to be a CRD, another CRD we're going to be creating here. You can assign different permissions, and you can create the instance sizes that you want, and then only give permissions to access them, but not to modify or create other ones, so that you're forcing the teams to use these potentially pre-approved t-shirt sizes. So what is this t-shirt size? It's basically cores and RAM for a Stackdress cluster. And for creating this, just create a CRD called instance profile, or use a CRD called SG instance profile. Just specify a name and the number of CPUs and memory that you want for this cluster. And that's it. This is just metadata. We'll not create any physical resource and create as many as we want. So let's actually run this. I don't expect to, well, we should write it to a file. So let's, we don't need to, but let's call this size small, SE instance profile, YAML, right? And let's apply this. And that's it. There's nothing special to do here. This is just metadata, and it creates this t-shirt size. Feel free to create as many as you want right now for this demo, or obviously modify any parameters that you want. So here, this size will give us 4 CPUs and 8 GB of RAM for a database instance. Good. So we have created this. The name is size small. Everything is on the demo namespace. We will reference it later. And this way, we are enforcing this best practice. You can create as many as you want. You will just reference the one you want to pick for your cluster when you create it. Now, I mentioned before that Stackdress comes with tuned configurations, but you can tune further. If you're a Postgres expert, you can go down and tune any parameters that you want. The way we could have done this is to, for example, embed the Postgres configuration as part of the cluster. But we don't like this option because maybe you also want to apply multiple configurations, the same configuration to multiple clusters. So it's better that it's just kind of a separate object that you can reference many times. Could it be a config map? Well, technically, yes, but then it will not be strictly validated. So we decided to create a CRD to support Postgres configurations. So it's also metadata, doesn't create any resources. It's called SG Postgres config, and it's pretty straightforward. Just assign a name to this configuration you want to have, specify the major version number that this configuration is going to be compatible with, and then for the PostgreSQL.conf file, specify the parameters. But note that these parameters, they're in YAML syntax. So you don't need to understand how this internally is going to be converted to a PostgreSQL.conf file inside of the pods. Actually, it's not going to be even written to a Postgres.conf file directly. It's going to go to a Patronic configuration. You don't need to understand any of this. Just set the parameters that you want, the values that you want, and we'll create this as metadata. And on top of all this, if you're not an expert, but you want to learn about this, I recommend you to go to this website, PostgreSQL.conf, PostgreSQL.nf, which is a website that will also build to help you work with Postgres parameters. On this documentation part, you can just search for any parameter, and we'll take you to precise documentation about this parameter that is also translated into several languages. Here you can see, and and you have recommendations, you have comments, and you can leave your own comments, etc. As well as there is a part of a service to manage your configurations. You can upload a Postgres config file, manage it, get a tuning guide about it, and it can really help you tune your Postgres parameters. So other than this, let's just create this configuration. So just copy this. Let's say this is it's called pgconfig1.postgres. Config YAML. It's going to be like this. It's just the parameters, right? So it's just a demo, and let's apply the file. Now, we can check on the demo namespace if we list the SG Postgres config. No. So if we list the Postgres configs, yeah. So again, it's SG PG configs. Then I see this PG config one, and if I describe this one, if I do the describe on the CR that I have created, it's very interesting because on the status section, I can also see, so here I see the whole configuration that actually is being used. You can see here there's more parameters than the ones that I set. This is because the Stackdress is tuning behind the scenes many parameters from you. Those we consider that are quite expertly tuned, and they're totally recommended, but you can override these parameters. So if you also want to understand which parameters are injected and which ones are coming from you, you can check on the status part of the CR and see that those ones that are on the default parameters are those that we injected for you. So far so good. This is again metadata. We just created a config called pgconfig1, and we will reference it later. Cool, let's continue. Now the same with connection pooling. For connection pooling, we use internally a software called pgbouncer, which is one of the most used connection poolers for Postgres. And by default, the configurations provided for you is tuned already. But if you want to override some parameters, you're free to do so. How you do that? Guess it. Yet another CRD. In this case, it's called SG pooling config. And so this is also metadata, pretty much the same. Assign a name and then override some pgbouncer.ini parameters. So it's pretty straightforward. In this case, I'm just gonna apply directly. I paste this, and we're good to go. And I've got the pooling config. And similarly, it will get some parameters injected. I can check on the status field. It's pretty much the same I did with the configuration. So now we have custom instance profile, custom Postgres config, custom PG bouncer config. So we're doing well. Let's talk about backups. Any question before we get into backups? Okay, I guess everything is going well. So backups, Stackdress is prepared to manage the backups automatically for you. Backups, we are using continuous archiving, which means you take a snapshot called base backup, plus all the differentials after this snapshot, which are called wall archives. So it's using a technique called wall archiving. And we decided in Stackdress that we want to also, because we're trying to enforce these best practices, that you will use cloud storage, or to be more precise, object storage, which is typically hosted on cloud storage, because it's one of the most durable places where you can put data. And backups should be on durable places. We don't want you to store backups on a file, on a disk drive, right? Wherever that is. So we support object storage and supports S3, Amazon S3, Google ECS, Azure Blobs, or any S3 compatible API, which is most of the stuff out there. You can even use, obviously, things like Mini.io, Wasabi, or Oracle cloud storage, because they're also using S3 API compatible. So what you need right now is one of these object storage or buckets. And you also need the credentials for those. This part may get a little bit tricky, especially, for example, to create a S3 bucket is pretty simple. To create a policy and retrieve the credentials is not that immediate. So depending on your environment, you may do it differently. I'm going to show the process, how to do it, particularly for an S3 bucket, because I'm running on Amazon. And actually, I have a script for this. So basically, there is, if I go to the repo, I've got a local copy here of the repo, Stackdress hands-on lab, and I'm going to go to a folder where I have some scripts. And basically, this is explained on the hands-on lab instructions that you have, but basically, I'll take variables.sample file, copy to a variables file, and edit this one. I just set some variables here. You can set your own, specifically you need to set up the bucket that you want if you're using a particular profile, whatever. And there's also another global variables file that you may want to check. This is what we're not going to be using. And here I have a script that will create an S3 bucket with all the policies. This is, well, a little bit complicated script. The key is that at the end of this process, it will output a command that will create a secret to store the credentials. So the way the backup configuration is going to work is we have a bucket or a blob storage, or however it's called in your environment. You will need to get some credentials to access this bucket with write permissions, obviously. And those credentials need to be put on a Kubernetes secret, because it's the most appropriate place to put this kind of information. And then we will create a backup configuration, which will reference this secret. So if I run the script this right now, at the end, it's going to output a command with kubectl to create a secret. You can do it differently, obviously. It's just for convenience reasons. Because this is going to, I could stop sharing the screen, but I'm not going to do this. But this is going to output some credentials. And so I'm just going to quickly copy and paste them. And or actually, to be more correct, I'm going to stop sharing the screen for a few seconds. I'm going to run this command. It takes just a few seconds. As I said, at the end, we'll output this kubectl line to create a secret. I'm just going to copy that, paste, run it, and then restart sharing the screen. I hope that's okay for you. You can also do this at home. And there we go. Running the script. Ready. I've got the command. I'm going to run the command. This is injecting the credentials into a secret, and I'm done. So now I have the secret created. Let me go back to share the screen. All right, and we're back. Cool. So we have created an S3 bucket, which we'll use for storing our backups, and we have created a secret. Should be here. Here we have This is a secret that we have just created 29 seconds ago. That will be used for storing the credentials of the backup. For you all following my steps that you're at this point, if you can do this fast, just go and do it, no problem. If not, you may skip this part. You will not get backups on your cluster, but I will show you how it works and how you get backups. But anyways, it's pretty straightforward. Sometimes the credentials are a bit hard to policies, permissions. They're a bit tricky sometimes depending on your environment, but you have the instructions to do it on the lab instructions. So we have created the secret that will store the credentials. Now we need to create a backup configuration. A backup configuration is, guess it, yet another CRD, because you can also share the backup configurations across several clusters. And this backup config has some specification first about the base backups, which is cron schedule, how frequent, or when do I want this base backups or snapshots to be taken. In this case, it's just for demo purposes. It's going to take a backup every 5 minutes, which is quite convenient. To also demonstrate this parameter, which is a retention window. This means that it will have at most 6 backups. And when a 7th backup is created, the oldest one will be automatically deleted. So it will have at most 7 backups. Normally, you'll have 6 backups created at any time. And then about the storage, I need to select the type, which will be S3, DCS, Azure Blob, or S3 API compatible, and then specify specific parameters for the storage type selected. In this case, it's going to be S3, and I need to specify the bucket and then the credentials. But the credentials, I just need to provide a reference to the secret. Within the secret, I can use any key to identify the properties of the credentials that I want. But this is the ones that I'm using. So let's just copy this configuration. Let's call this SG backup config. There we go. And let's edit it. So I need to replace the bucket name, and the bucket name is, I'll get it from what I had here. So this is Stackdress hands-on lab global viruses here. So the bucket is called like this. It's very important, by the way, about backups in Stackdress that you write this config file well, because if you have mistakes, you may end up with weird problems. There is no, as of today, validation that this CRD is created correctly before creating the cluster. So you may only see that there is a problem when you create the cluster. And then I need to replace the secret name, which is called like this. So I can say replace secret name with this. Oh, bad luck. Sorry, typos. Okay. So this is the name of the bucket. Let's close it. And the name of the secret where the credentials are stored, which should have this property. Okay. So if all's good, I should be able to keep it apply this SG backup config, and the backup configuration will be created. That's it. So we have created instance profile, Postgres config, connection pooling config. We have created the secret to store the credentials to access the S3 bucket or the object storage, and now a backup configuration. Excellent. We're almost ready to create our Stackdress cluster. But before that, let me explain you about yet another functionality that comes with the Stackdress, which is called a distributed log server. In reality, or by default, the Postgres logs, as well as Patroni logs, they are written to the container, which is ephemeral storage. We'll not get very far with this. And you can check the, sorry, they're not written to the ephemeral storage, they're written to standard output. And this you can query with kubectl logs, which holds a ring buffer of the latest logs. You're not gonna get very far. This shouldn't be the way to store Postgres and Patroni logs, which are quite important for troubleshooting in databases.
In Stackdress, we have developed a technology to take the logs from the Postgres containers and ship it to a central location. So all the logs from all the pods, potentially of all the clusters that you want, they're going to be sent to a central location. And this is called a distributed log server. And this distributed log server stores the logs. And where does it store the logs? On a Postgres database. Isn't that cool? Because we want to store the logs structured and in a way that you can query them with SQL. Because this is for Postgres. We are Postgres people. And we know our DBA experience that sometimes you really need to find very complicated information with logs, which if you could express in SQL, you'll have a lot of power. And you may think, oh, yeah, but logs have high volume, potentially high velocity. Postgres is not going to be able to keep up, even if it's a separate database from the cluster Postgres database for obvious reasons, right? But in reality, we're using time series extension for Postgres called timescaledb, which is pretty awesome and allows this to support this high volume and high velocity ingestion of logs, which are obviously time series data. So if you want to support distributed logs, then you need to create one or more distributed log server. This distributed log server will use resources. The previous configurations we have done, they were just metadata. This will create resources, and this, but it's a separate Postgres database. And you can have multiple clusters feed logs to a single distributed log server, or you can create multiple distributed log servers. It's really up to you. So in other words, they're multi-tenant. How do I do this? Simple YAML file with yet another CRD called sg distributed logs. So just give a name, give a size, and internally, this is just a simplified Stackdress cluster. So it's behind the scenes, the simplified SG cluster. So let's just run this. Let's say pipe to kubectl, apply to F from standard, from standard out input, and paste this. And this is going to create this distributed log server on the demo namespace, and we'll create a Postgres cluster called distributed logs. Excellent. So at this point, we can finally create a more advanced cluster. And what we mean by more advanced? By more advanced, where it's still not very complicated. This is the whole YAML file that we're going to be using here. But the changes that we're using here is that we're going to create a namespace to have more organized. We're specifying a Postgres version, explicit one, but then we're specifying the instance profile that we want to use, so the size of the instance that we're going to use by referencing an existing instance profile, enforcing these recommendations of standardizing on sizes. And then I'm specifying the three configurations that I want to have specific for this cluster: the Postgres configuration, the connection pooling configuration, and the backup configuration. And then I said that I also want distributed logs using this distributed log server. And finally, I want Prometheus metrics to flow automatically. And so I just need to set this flag to true. And that's all. So let's copy this. Let's create a YAML file. By the way, distributed log server is already up and running. That's excellent. So let's cut this to, what is this name of this? Whole, okay, so whole sg cluster.yaml. Let's paste the file here. Let's review the file one more time. And if all goes well, hopefully I also created the backup configuration well, then we should be able to kubectl apply this file, and soon enough, the cluster will start to be created. Okay, pause. And here we are. This is creating. Any questions so far? Well, this creates. Let me just double check on the chat here. Okay, I see some questions here. Answered. Excellent. Okay, so once we have created this, what we're going to do is check that everything is correct. So we'll get the pods. It should look like this. We'll just wait a bit and then double check. And also let's check on the web console, because why not? We have it. So let's change the demo namespace. And okay, yep, looks like there's a cluster being created here. It's creating. So far so good. 6 or 7 containers. Okay, excellent. Let's wait a little bit until this finally obviously gets created. First node is already up and running. That's excellent. And then once we have this, let's connect to Postgres. The way I connected to Postgres before was a little bit hacky. Well, it actually was not hacky. It's the way you would do from administration. But in reality, the way you will typically access the Postgres database is going to be externally. It's not going to be running a command inside of the container that's part of the pod. It's going to be from another pod running on potentially another node, obviously, accessing via a service. So Stackdress, when you create a cluster, automatically is going to expose two services to the cluster. The first one for read-write workloads, which will always point to the master, whatever it is. And the second one that is a load balancer to all the replicas, whatever they are, the replicas. And if anything changes, the services will point correctly to the new master or replicas, primary or replicas. So this case, we're gonna connect externally. How we're gonna connect externally? Running an application on a separate pod that will connect to the service. And which application can we run? Well, we can run any. The simplest one is psql. So what we're going to do right now is run a separate container, and this is the key. It's a separate container that with an image that contains psql. I'm going to use the same image that is in Stackdress called Postgres util that contains psql, and I will specify -h, which is the host, to connect to the host, and I will use here the service. This service, well, this is, oh, it's already created. This is pretty good. By the way, we can check that everything's okay by checking with Petroni that everything's okay here. Just to double check. And yeah, looks good to me. And so I will connect, I will run this command to create this psql and connect via the service. The services that are exposed, I can query them, and I will see that, well, this is for the distributed logs. We don't worry about this. But for this cluster, I have a primary service and a replica service. That's what I was referring to before. So how do I connect to it? Via this whole dash primary service. In this case, if I want to connect to the read-write one. So here we have the command. Let's just copy and paste this command. It's pretty straightforward. And I should be able to get a connection to the primary service. So even though this looks pretty similar to what we did before, what we're doing here is running a separate pod with this container image and then connecting to the DNS name that will resolve to the service that in turn points always to the master. There's a problem asking for a password. I don't know the password, type whatever. So I failed. Why is this? Because because we're connecting via the Postgres web protocol, Postgres is configured by Stackdress to require a Postgres password, which we don't know. The Stackdress on installation and creation of the cluster creates a randomly generated password. So we can retrieve this password because guess what? It is stored on a secret that also Stackdress creates. So how we get the secret is also more or less straightforward. Well, it's just a simple secret, right? But let's just get it from here. And I'll just copy to the clipboard to show, sorry, not to show any confidential information here. If I manage to type it, thank you. No, my bad. And this will copy to the clipboard this automatically generated password. And now I should be able to finally connect to the database. I paste this and yep, I'm connected to Postgres. So now we have demonstrated that we can connect externally, not by running a command inside of the container, to Postgres. This is how your application should be doing. So just use this DNS name or hold that primary dot demo, which is the namespace where we're running. There's a valid DNS within the Kubernetes cluster, which you may use to connect to the Postgres service. And obviously, if you want to connect to the read-only one, you can connect to the replicas, which is again load balanced. Right now we have only one replica, so it will only point to one. And we can double check that this is our replica, because if we call PDC in recovery, it should say true, which means that is read-only. Read-only. Okay, good. So What about the logs? I mentioned that the logs are sent to this distributed log server, and this sounds like, wow, pretty cool, but show me. So it's pretty easy to access the Postgres console because, as I said before, this distributed log server internally is just an SG cluster. So it'll also have its own service like this primary and its own credentials and everything. So if I just go to the command that retrieves the secret, and instead of asking for the secret for whole, I say SG distributed logs, which is, if I recall correctly, the name, no, sorry, it's distributed logs. The name I assigned to this distributed log server in this YAML file that I created, I should be able to retrieve the credentials to connect to the distributed log server. And then if I repeat the pSQL connection, but instead of connecting to the whole service, I connect to the distributed logs primary, there's no replicas in this case, and paste the password, then in this case, I'm connecting to the log server. How we can see this? If I could, for example, list the databases, and I see that indeed there's a database called namespace _ cluster name. And this also demonstrates that this is multi-tenant. If I had multiple clusters feeding the logs to this location, they will have different databases here. So let's connect to this database. Let's see what is in there. Demo whole. And here we have some tables. Log Postgres. How does it look like, this table? For example, the logs for Postgres database. As you can see, these logs are quite detailed. We segregate in different fields a lot of information about the Postgres logs. How do they look like? So it's not very useful. Let's switch to extended display mode. And here we can see, yeah, indeed, here is a log about a connection received, authorized connection, disconnection. Well, logs are going to be a little bit boring on this cluster right now. But before this, I just did an error. Let's look for this error because it's actually quite interesting that I could, for example, let's list again the structure of the table. You see that it has a field called error severity. So let's say, so let's start from log Postgres where error severity equals error. Well, I know it's written like this, but actually it's demonstrated that I could do select error severity. Let's also say, for example, count from log Postgres group by 1. And this will tell me that there's actually 588 logs and there's one error. It's probably the one that I just made when I tried to create a database inside the replica, which obviously is read-only. So let's get actually that one. So let's start from log Postgres where error severity equals error. Now we know exactly how it's written. I'm not cheating. And indeed, this is exactly the error I did before. And I did, by the way, this was not planned. I did it before. So here we see that this is very cool because all the logs from all the pods, this I did on the replica. So all the logs from all the pods, they're being fed to this distributed log server, which is another Postgres database, which I can query from SQL. And I can do any magic that I want with SQL to query my logs. Now, you may say, hey, Alvaro, at the beginning, you told us that everything here is going to be like very high level. You don't need to be a Postgres expert to use Stackdress. And fair enough. This is actually not even being a Postgres expert. It's more of a SQL expert, which are many more than Postgres experts. But fair enough, you may not want to do this command line interface, low-level interface, or by doing queries, but also you can create applications to parse logs from here. This would be pretty straightforward with Stackdress. Logs should also appear on the web console. So let's go one moment to the web console. Let's look to my cluster. Looks very healthy right now. And here I see a pane called logs. So if I click here, indeed, I see all the logs here. Then I can click on any log and I can see the details about this log. And then I can do filtering. For example, I only want to see Postgres logs and I want to see only errors or others. I can search and apply these filters. And then this, I get all the information here. To be honest, I'm using a really large font here, so I cannot see a lot. But you can see that you can see the logs here without having to do a query to the database. So you can have the best of both worlds and search here or apply the logs via SQL queries. Also, now that we are here, let me show you about the backups. That, yep, we have already 2 backups being created. So as I told you, we configured backups, they're being created automatically. And about monitoring, even though my purpose today is not to show the web console, but if everything worked well, we should see the Grafana dashboards embedded here, and I can see the traffic here and all the dashboards that we have created, checkpoint direction stats. There's a lot of panels here, as you can see, that tells us all the information about the database, and it all appears here in this web console. Cool. So we have created cluster distributed logs. We are very advanced on the lab. Let me show you, before moving to the next step, let me show you a couple of things. First, I also explained that everything in Stackdress needs to be GitOps friendly. Everything needs to be in our philosophy represented by a CR, which corresponds to a CRD definition. And right now, this cluster is taking backups automatically. And we can see these backups here on the web console. I clicked here on the backups. These are the backups. By the way, we have a third one on the way. Done. We have these backups here in the web console from this cluster, or I can go here for the cluster backups for all the clusters. In this case, I have only one, so it's pretty much the same view. And if I click on any backup, I can see, on the backups, and any backup, I'll see a lot of information about the backup. When it was taken, the size, compressed size, LSN, a lot of internal details, and even control data, which is very low level information about the backup. Everything here is shown to me, and all this was done automatically. There's nothing I need to do. But as I said before, we're showing command line here today. So let's show the same from the command line. How we do this? The backups, even though they're taken automatically, they're also represented as a CR. So Stackdress create the backup and then creates a CR so that we see a representation of this entity. I was going to say physical thing, but it's not very physical, as a CR. So if I just go to kubectl demo get SG backups, then I will see the backups that exist. And if I want to see the details of any of them, I can select them by name, for example, and I will see the details of this backup. And all the same information I'm seeing on the web console, I also see here, including all the control data information. This is quite low level, as well as the backup details. And this is created automatically for me for any backup that is created in Stackdress. So interesting, we have shown status. By the way, this is quite convenient just to have here, click here, and you'll see the connection information, connection help, but you've seen how it works already. Here's a summary of the configuration, including the exposed services and backups we have seen, logs we have seen, and monitoring the embedded dashboard we have seen, and the same from command line. So let's move. We only have 2 items left for this lab, for this demo. Let's go to the first one, which is extensions. And Postgres extensions are possibly one of the most appreciated features of Postgres. Postgres is well known for many reasons. One of them is extensions. It makes Postgres amazing. You can extend functionality with a lot of capabilities. But extensions are hard on managed environments, cloud managed environments, as you probably know. If you go to RDS, to Google Cloud SQL for Postgres or Azure Postgres, the set of extensions available is limited. It is up to the cloud provider to decide which extensions are whitelisted and are permitted because of various reasons. On Kubernetes, with the containers, it's even harder because container images, to be more precise, are immutable. So every time you may want to add an extra extension or may just want to update the version of that extension, you should be providing a new image for that container. And even worse, you'll need to restart your cluster to make use of that image, which causes downtime. So this is unacceptable from our perspective, just to add a new version of an extension. So for Stackdress, we have developed a new mechanism that allows to dynamically load extensions into the cluster at any time on demand. So let's connect for a moment to our cluster via the console. For example, here, I'll need to retrieve the password. So let's get the secret, not for the distributed logs, but for the whole cluster. Copy the secret, connect to the Postgres instance. I could have used also cpsql directly, but any case. And if I there's a function in Postgres that returns the available extensions, pg available extensions. And this basically goes to the file system and checks which extensions are available. And here we see an extremely limited number of extensions available in Stackdress. Doesn't look good to me. That's not enough. What if I want to install, for example, L-tree, which is a convenient extension to create hierarchies, trees, right? So let's go for a moment to our cluster YAML file. And we have also the process of installing an extension may be actually quite complex. And again, following our same principles, we have managed to build the system in a way that it only exposes very high-level interfaces. So let's just add here another field called Postgres extensions. It's an array of values, name, and let's say L-tree. I want to add extension L-tree to my cluster. So I just added the config file. I just added the last 2 lines here. I'm doing this a bit live. I should copy and paste, but okay, let's give it a try. If I fail, I fail. And if I apply this file, Kubernetes should detect that it's a change, will apply to Stackdress, and will apply this change. What Stackdress will do is has a local pod inside of the cluster that will be responsible for contacting the repository, download the extension, and put it into the container. And this will happen anytime Postgres is either running or even restarted. If it crashes, it will start back again with the same image, which doesn't contain the extension, and then the extension will be put automatically by Stackdress. So if I go here and repeat the query, I see that this L-tree extension has been loaded dynamically for me. And now I can just go and say create extension L-tree, and I'm done. So here with this mechanism, we have solved a significant problem, which is the availability or the very limited availability of Postgres extensions in other cloud environments or Kubernetes environments. And right now we are preparing a large catalog of extensions. As of now, there's no specific mechanism to check all the available extensions from here. There is from the web console. So if you go, for example, to create a new cluster, this is the web console dialog for creating a new cluster. Here, there's an area for Postgres extensions. And if you click here, you can see all the extensions that are currently available. And if you want to know more details of a given extension, you can just drop down here, see the description, the available versions. There are some of them, and you can play with them. We have included some important extensions like PostGIS. There's timescale DB with several versions and more to come here. Also included 2.2.0, 2.3 is coming down the way, and many more that are going to come in the future. So there's a lot of extensions available today on Stackdress and more to come. So it's going to be fully featured cluster. I think I didn't skip anything here, but yeah. And let's go to the very last one. This is one of my favorite ones. So most environments, managed environments, Kubernetes environments have focused on automating mostly the deployment component of Postgres. And that's pretty cool. It's amazing. You get a lot of value from it. And you get automatic failover and backups and monitoring. But this is only about deployment. How do I get my cluster, Postgres cluster, with all the nuts and bolts that I want running, up and running? So far, so good. But what about the next day? What about what is so-called day 2 operations? Now it's running. That's fine. I've got my logs and my backups and everything, but I need to do some tasks to manage my Postgres cluster. For example, I want to run a manual vacuum, or I want to run a PG repack, which is a critical operation to actually remove load, which is a phenomenon that happens quite frequently in Postgres and makes your performance great, up to the point that you may break, and this happens a lot, your SLOs, right? So removing bloat is an important operation. And to use PG repack, you need to pass some variables, some configurations. It's not that it's super complicated, but again, our philosophy is to make these operations as Postgres agnostic as possible, so that if you at least understand what the operation is going to do, and you know Kubernetes administration, at least the basics, basically how to create a YAML file and execute it, you will be able to perform these operations. One of my favorite ones, just because everybody loves benchmarks, who doesn't, right, is that we have also automated running benchmarks in Stackdress. It's not that it's super complicated to run a benchmark, but it's a tedious task to run a benchmark, remember the flags, the appropriate ones, and then collect the results. So what Stackdress does is offer an interface for running these so-called day 2 operations. We call them DBOps, or database operations. So we have yet another CRD called SGDBOps, which supports several operations and encodes in, again, I hope, a high-level interface, the parameters that you need to set to run operations. In this case, let's run a benchmark. So we just assign a name to the CR, compulsory, obviously, right? We select the operation to be benchmark. The current operations supported are benchmark, vacuum, repack, minor version upgrade, major version upgrade, security upgrade, this is the upgrade of the container images, and restart. Those involve controlled restart processes with controlled failover. This is pretty evolved operations. But let's focus on benchmark right now as an example. So I specify the operation benchmark. I point to the cluster where I want to perform the operation, and then I specify operation-specific parameters, in this case for the benchmark, of what I want. So the type is pgbench. It's going to run a pgbench. In the future, we'll support all the benchmarks. And then some parameters for pgbench, to the database size, the duration. Let's run for 2 minutes, just to make it run fast. We're not going to use prepared statements, whatever, concurrency, number of threads, etc. So let's just copy this, and let's leave this here, and let's just apply this. Tell apply from the standard input. And again, this is going to create an SGDBOps. Let's list the SGDBOps. We should have this one here, and let's watch this operation. So this is fully declarative. Actually, we have seen the sequence in a perfect timing, because when I create the CRD, it will not start the operation right away. By the way, SGDBOps supports programming this operation. So you can say run tomorrow at 7 a.m., 52 seconds, whatever you want, and it will run automatically for you. You don't specify timing, it will run ASAP. So in this case, we see that the operation started running and it's running the benchmark. We can see, for example, if you go to the web console, monitoring comes with a few seconds of lag, so we'll probably not see that. But we can go to database operations here, and yeah, indeed, we see that the benchmark here is running. It's been 49 seconds running. So okay, I said for 2 minutes, it needs a little bit more time to create the data that is later we'll use for running the benchmark. So probably around 3 minutes, we'll have this operation finished. When it finishes, we should be able to do a describe on the SGDBOps called pgbench1, and we will see the results of the benchmark. Right now, we see that the operation is that this condition called operation running is set to true, which means that the benchmark is running. When it finishes, on this status field, we will see written an object which describes the result of this benchmark. And this is, well, we believe it's quite powerful, that with just another simple YAML file, I didn't write it, but looked like this, right? So a simple YAML file, anyone can run a benchmark and obtain the results automatically, in other words, programmatically, without having to understand how pgbench works, which even if it's not super complicated, we're abstracting away this complexity. Tomorrow, maybe we'll support a more advanced benchmark that requires a lot of effort to set up, and everything will be programmed, so you will not need to worry about it. And you'll just specify instead of type pgbench, type pg, whatever it's going to be, and it will run it for you. And that's the power that we wanted to bring here to Stackdress with these day 2 operations. It's not finished yet, but should be in a few moments. While we wait for this to finish, I basically, yeah, this is the last part of this hands-on lab tutorial that I wanted to bring you today. There's many other things we could do here. But I hope that after following all this, you get a glimpse of how to run Postgres on Kubernetes in a totally production quality, production grade way, with a lot of advanced capabilities that have been built into this fully open source project called Stackdress, including the embedded monitoring, including the distributed logs, including the dynamic extension loading mechanism, the automatic database operations, the web console, which is fully featured. I recommend you to use it, even if I'm a CLI person. I use it a lot myself. It's very convenient with the integrated monitoring. And this demonstrates that in a couple of hours, including a lot of explanation and starting from the very, very beginning, from absolute scratch, from not even having a Kubernetes cluster, we've come to the point to have a very advanced Postgres cluster, which includes replication, failover, automatic failover, includes connection pooling with a customized configuration, Postgres configuration, customized configuration. This distributed log server, automated backups, provides this web console, these distributed logs, etc. So it's quite advanced environment that with just a few lines of YAML, few files in YAML and usual Kubernetes patterns, you are able to create very advanced production quality designed by DBAs Postgres clusters. Let me get on this because it's probably done by now. Yep, exactly, it's finished. So here you see the status. And here we see that in this case, okay, this ran 1700 transactions per second based on the configuration that we ran. And all the results of the benchmark are captured here in the ST DBOps for me. So quite convenient because with just a few lines of YAML, I can run a benchmark, capture the results. I can even program these operations. If I want to run 10 benchmarks during the weekend, I can just create 10 SDDBOps, program at different times, and I'll come back on Monday to see the results. And that's it. Pretty convenient. So that's the end of my side. More questions or some questions?
It looks like everything got pretty well handled in the chat here. I don't know how things have been in the Stackdress Slack, but definitely quite active here, and it looks like everyone was quite happy. So, all right, let's take a look. See if we can get any direct feedback. But I think that was quite complete, and we even finished 3 minutes early. So that's there was plenty that was done in that amount of time, as well with a couple of demo effect moments. But that's part of the charm, right?
It is.
So anyway, I think there's within a 2-hour period that we can successfully say that Postgres is working on Kubernetes is no small statement, particularly because Alvaro and I have seen some other statements mentioned in social media in the last few weeks. So this is a very, very healthy way of getting this out in the open and showing everybody how it's done. That being said, Alvaro, when you give a lot of talks. Do you have any talks on the horizon, on the radar that people should know about?
To be honest, I'm trying to slow down a little bit. This month of June, I think this is my 6th talk.
Oh, wow.
Yeah. And probably around the 15th in the whole year so far to date. But still, I have one next week. And it's going to be a Postgres specific talk on the pgday.ru, so conference in Russia. It's virtual. And I'm going to talk about, I'm trying to respond to a question which says, can Postgres scale like DynamoDB? So if anyone is interested, it's not published the agenda yet, but you can go to pgday.ru and that talk will appear there. I think it's going to be on July 8th or 9th.
Okay. Yeah.
So maybe it's the week after.
What's good? You're pretty easy to find in Twitter, LinkedIn, etc. We'll try to get those things shared out. As usual, we had a artistic contribution from Angel, our graphic recorder. So if you guys give me one, you already know this happens every time, Alvaro, so there's not as much of a surprise factor. Let's take a look though. Let me see if I can get this. All right, let's see. So I'll share my screen real quick. There we go. Alrighty, 1 second. Good. So I think everyone can see this. Alvaro, let me know when you can.
Wow.
So we got a Postgres race car today. And anyway, there was a lot of stuff covered here. So obviously this is just a summary, but I think, there's a reason why we've had Alvaro as a speaker multiple times, and it's because he does a really good job. And extremely on top of it, answering questions. Big shout out to your team as well that was in the chat. As I said, get in our Slack, get in the Stackdress Slack. If you want questions answered, you've got all the support and know-how needed. You've got people that speak multiple languages. If English isn't so much your thing, you can speak Spanish, you can speak Portuguese, probably get some other things in there too. So don't feel that is a barrier. Alvaro, it was wonderful having you. Thanks to everyone in the audience that attended. We had really, really good numbers. We'll be publishing the video for anyone who arrived late. In case you didn't get word there from the beginning, the video will be up in no time. And in no time, I'm sure we'll be having Alvaro back as a guest. So as usual, thank you so much for your time, Alvaro. It was fantastic. We still have to get a Postgres panel at some point. Got to get the right mixing and matching for that. So that's definitely something on the horizon. So keep your eyes open for that too. I don't know if there's anything else, Alvaro, that you'd like to share before we close.
No, I just want to really thank you for the amazing effort you're doing with the Data on Kubernetes community. It is really an honor for me to be here. And for these drawings, I love them. And also, as you said, for everybody attending, obviously, I hope that you had a great time. Probably you want to follow up, probably you want to keep trying this hands-on lab. Everything's public, so just keep working on it. And a special thanks for my team, not only for the amazing job they're doing with this open source software Stackdress, but also for being here today, helping me answer questions that I couldn't take while doing this demo. So actually, thank you, everybody. I'm very pleased to hear and do this.
Good. I don't think we can have enough positive moments in 2021. This is a very, very good one. Thank you all to everybody. Stay out there, be safe, and let's continue the conversations about how to make data work on Kubernetes. All right. Thank you very much. Have a good one, Alvaro. Take care.
Thank you.
Bye-bye.
Goodbye.